In this movie, we'll take a look at a Unix program called sed. Sed is short for stream editor. What that means is that sed modifies a stream of input according to a list of commands before passing it on to the output. That's very similar to the way that tr works, but with sed we can modify the stream of input in many more ways. Sed is a complex tool that offers several modes of working and many features. In this movie, we're just going to focus on the basics and get to see the most common usage. Its most common usage is for doing substitution, and so what we'll be doing is sed space and then providing an expression for substituting. That will always begin with the letter S inside the quotes to indicate that it's going to be doing substitution. Then we've got some delimiters, the / in my example, and then we've got patterns of searching and replacing, just like we had with tr. So we're going to search for whatever's in A and replace it with whatever is in B. Notice that the big difference between this and tr, though, is that tr actually had two different arguments, right? It had tr, then the first argument, and then the second argument. Here, they're all in one argument, and they're inside those delimiters. Sed is really based on this one expression. So everything that we want to do, the sort of command that we're sending to sed, is going to be inside those quotes. Let's take a look at some examples. So for example, let's take some input, echo upstream, and we're going to pipe that into sed. So then what we need here is an expression inside quotes for substitution. I'm going to go ahead and put my delimiters. Now inside each of these, we're going to need to fill in what we're searching for. I'm going to search for up, and we want to replace it with down. So upstream becomes downstream, which is appropriate since we're doing stream modification. Upstream it was upstream, once it gets downstream it's downstream, in between is sed, doing the stream editing. Now notice how this is different from what we were doing with tr. tr was translating each of those, right? What we're doing here is we're searching for one thing, and we're replacing it with something else. It's much more like the find and replace that you might do in a word processing program. Now there's one important thing I need to show you about sed, which is that by default it doesn't search globally. Let me show you what I mean. So let's say we have upstream and upward, and then let's just hit return. Notice now it changed the first occurrence of up, not both of them. Just the first one got changed. That's different from what we were doing with grep. When we were grepping for something, it was finding all occurrences of it. And that's because grep, the G, stands for global. It's globally searching. So just like grep, we need to provide a G modifier here to say that we want to do this globally. So after this pattern of S and then a replace string, then we put a G to say that we'd like to do that globally. Downstream and downward, now it does both of them. Now, the delimiters that we're using here, these /, actually are modifiable. It doesn't actually matter which one you have. Let's do, for example, colons. What sed does is it says, all right, what's the first thing that comes after the S? Right? I see the S. I know we're going to do a substitution. What delimiter should I use? And whatever we have as that next character is what it will use as the delimiter. So we can use pipes like that. Still works. I'll just paste in an example to show you why you might want to do this. The /s are really the most traditional usage of it, but let's say, for example, that I had a phrase like macOS /Unix : awesome, and I wanted to change that. Then the search string that I'm looking for has a / and a colon in it, so I don't want to use either of those first two choices, therefore I'm using the upright pipes. Now I could still use the /s, I would just have to escape each of those values. Every time it occurred, I would have to put a / before the / to escape it. By switching to a different delimiter, it can just make it a little cleaner and easier to read. So far the stream that I've been using has been text that I'm piping into sed, but sed also works with files. So let's say we have sed s, we'll use pear to mango inside our fruit file. And I'm already inside my Unix files here, inside my user directory. We have a file of just fruit there. Now notice that I did not put the pipe here. You certainly can, that still works too. This is different from tr. tr, you had to put this there. With sed, you don't have to. It will take a second argument, which is the file that you want it to do. And then we can take that and we could pipe that and we could have something like mango fruit.txt. Now we've redirected the output into this other file. Now notice here that we did not use the G modifier, right? When we did that, we didn't use the G modifier, but at the same time it replaced pear here and it replaced pear down here 2 times. Why is that? Well, it's because each line gets treated as a stream. Let me show you an example where you can really see this in action. SA to X, and we'll do that with the fruit file. Now notice here, when we had, for example, banana, it only changed it the first time. It didn't change it the second time, but it did do it on the next line, right? It found the first occurrence and then the first occurrence and so on. But then it got down to papaya, it only used the first one. We didn't do it globally. If we switch that and you do the G in front of it for global, now notice that papaya all got changed, right? So it's line by line. So when we say global, we're saying per stream, and each one of these lines is being treated as a new stream that's coming in. Now you can search for just about anything inside a file and replace it. It's useful for things like, let's say we had a file that was written in Britain, right? So it has the word color in it, spelled with O-U-R. We want to change that to color, the American spelling, without the U. Then we put that global and whatever file we want to work with. Now obviously I don't have the word color in there, but that's the kind of thing you could do globally to a file, and sed would make it easy. You can also provide multiple sed commands. Let's say, for example, that I have a phrase like echo during daytime. We have sunlight. And let's take that and we'll do sed. And we want to first do S for day and night. Okay, that will simply replace the day with night. So now it says during nighttime we have sunlight. If we also wanted to replace sun with moon, we could provide a second command. And the way we do that is you put dash lowercase e. It's important that it's lowercase. And that says that we're going to have multiple commands. We're essentially going to build them up. So dash e in the first one, dash e, and then the next sed command, S sun/moon. There we go. And now it does both of them. So all you have to do is prefix it with that dash e option. And it says, oh, what comes next is an argument to dash e. Therefore, I'm going to take that as one of my sed arguments, and I'm going to wait until I get another dash e. And I'll take that and just sort of build up the set of filters that we want to apply. So that's nice. You can actually put together 5 or 6 of these and change a whole bunch of things all at one time. And you can remember that it's the E because E is for edit. So we're providing the edits, right? So each one of these is an edit that we want for our stream editor to use. Now we won't go over it, but if you have a lot of sed commands that you want to run on a single input stream, then what you can do is you can put all these edit commands into a file, and you can use the F option to run all of them at once, and it'll run every sed command that's in the file. So you can have a set of regular things that you want to change, sort of filters you want to apply, save them to a file, and they're available to you. Anytime you want them, you can just call up that sed file and say, hey, run all of these commands on this file for me. Now these all give you some examples of just the simplest substitution that you can do just by using literal characters. Where sed really becomes powerful is when we start working with regular expressions, and that's what we'll look at in the next movie.